Alright, in this video we're going to talk about the inverse of a function. So what we're going to do is we're going to take a function, we're going to invert the x and y values. In other words, we're going to exchange places with those, okay? Now it doesn't always have to be the x and y. What we're really doing is changing the independent and dependent variables, and then we're going to solve that new function for our new y or dependent variables. So let me show you what that's going to look like. So for example, here in this first one, what we're going to do is we're going to realize that f of x is the same thing as y, so I'm going to go ahead and make that change. But then I'm going to switch x and y. So I'm going to put x where y was and y where x was. And now I'm going to solve that equation. Now I'm going to solve that function for y. So the first thing I'm going to do is move the 2 over. Right? Then we'll multiply by 4 over 3. Okay? Multiply by 4 over 3 because then I can see that the 4's will become a 1 and the 3's will become a 1. So all I'm left with is y on the right side. And then on the left side, what I have is 4 times 3 over x minus 2. Okay? Now then, the next thing I'm going to do is I'm going to write this back in inverse notation. So I'm going to say f inverse of x. So I'm going to change this y back into the f of x form, but now because I've switched my x and y and then solved, that's what's going to indicate that it's the inverse. And then I'm just going to write the new function that I have, which is 4 over 3 x minus 2. So now these two functions, f of x and f inverse of x, are inverses of each other. Okay, so one more thing I want to show you is to check your work to make sure you've done it correct. I should be able to make composition of functions. So I'm going to take f of f inverse x. So I'm going to take my inverse function and go plug it back in right here, and let's show you what's going to happen. So now if I go back and do that, so I have 3 over 4, and I'm going to plug in my new function, which is 4 over 3 times x minus 2. And then I have plus 2. So again, all I did is I took my inverse function, plugged it back in here for the x, and got this right here. Okay? So one thing I want you to notice, if I were to take these two items here and multiply them by each other, that just turns into 12 over 12, right? So 3 times, right? So 3 times 4 is 12, 4 times 3 is 12, and then 12 over 12 is 1. Or you can notice that these simply just turn into a 1, right? 4 over 4 is a 1, 3 over 3 is a 1. What I'm left with is x minus 2 plus 2, and if I drop the parentheses because they're not necessary, I'm not distributing anything in this set of parentheses here, then you'll notice minus 2 plus 2 is 0, so the f of f inverse of x is simply just x. So if you have correctly found the inverse of a function, every time if I make the composition, it's going to end up just being x. So that's one way to check to make sure you've done your work right, is to plug the inverse back into the original, evaluate, and see if I get x. And if you do, you'll know you found the inverse, and that will happen every time. All right, so they ever ask you if two functions are an inverse of each other, simply take one function, make a composition with the other one, simplify, and you should get x. All right, so here's another example. Once you pause the video, try that on your own, and then we'll come back and check it together. Now that you've had a chance to check that on your own, let's look at it together. So I've got y equals x over 3 minus 1. I'm going to switch my x and y values, and then I'm just going to solve for y. So I'm going to add 1 to each side. Got x plus 1 equals y over 3, multiply by 3 to each side. Those turn into a 1. So now what I've got is f inverse x, right? I changed this y into the f inverse x because I've flipped my x's and y's and now solved. And that's going to equal 3 times x plus 1. So now to check, I'm going to take my new inverse, I'm going to plug it in right there and see what happens. So I know that if I make f of f inverse of x, I should get just x. So I'm going to take that and plug it in. So I have 3 times x plus 1 on top over 3 minus 1, right? So I've taken this entire new inverse function, I'm going to put it in the numerator here, which is what we get right there. And if I'll notice, the 3's become a 1. All I have is x plus 1 minus 1. Plus 1 minus 1 becomes a 0. So I have f of f inverse of x is equal to just x because those become a 0 and I don't need them. Now I know that that is in fact inverse because my composition is just an x, right? So this is the inverse of that. All right, that's how you do it with equations. All right, so now if I look at it from a table, right, I'm going to look at f of 0. So I know that 0 is an x value. So I'm going to come over here where my x is 0, and I'm going to notice that the y value that corresponds to that same point is also 0. So I know f of 0 is 0. Now if I go look at the next one, it's a little bit different. I have f inverse of 2. So that 2 is not an x because remember in inverse, I take the x and y and I flip them, right? So I know this 2 is now a y. So I'm going to come over here where y is 2. I'm going to go over to my point that corresponds with it, and I'm going to see the x value that I would have used here was a 4. So I'm going backwards in this situation. So what I know now is f inverse of 2 is 4. All right. Now I want you to pause the video. I want you to try these two by yourself real quick, and we'll come back and check it. All right. Now that you had a chance to try that on your own, we're going to come back and look at this. So this is just f of 1. So that's normal, which means my x and y are not flipped. So I know that 1 is an x. So I'm going to go over here to where x is a 1. I'm going to go up and realize that my y value that corresponds with it is also a 1. So f of 1 equals 1. And now on this one right here, I have so this should be f inverse of 3, and because it's f of inverse, I've taken my x and y's and flipped them, so I know that 3 is a y. I'm going to go over here to where my y is 3, go over to where that meets the graph, and I'm going to go down and see the x that corresponds with it, and I'm going to realize that it is 9. So f inverse of 3 is 9. Okay, so that's how you're going to do it in a graph. You're going to pay close attention and notice, hey, do I have the inverse? If so, I know this number is going to be a y. And if there is no inverse, like here and here, I know this number here and here is going to be an x. All right, so real quick recap to find the inverse of a function. We take my x and y, or my independent and dependent variables, we're going to flip them, and then we're going to solve for y, or our new dependent variable. And this right here, when I have the f inverse, that is the notation of how to do it. I do it with a small -1 superscript by the function name. All right, hope this video helps, and we'll see you in the next one.